So what we're gonna do is I'm gonna make a few shorter videos with individual example types. I may eventually compile these or edit them into a single video, but for the sake of getting stuff out to you guys quicker, I'm gonna do some smaller, chunkier videos where we look at a specific example type and we do some of those. That way you have some information, you have some examples worked out. Um, and then we're ready to go. All of those things. So we have been talking about logarithmic equations in this particular lesson, and in this particular last couple of lessons, really. We are going to, in this particular lesson, or in this particular video, we're going to look at some examples, two of them. So I split this into two halves, where we did we did some other examples where our method to solve it was to convert from logarithmic to exponential form. Now in these, we're going to do it the other way around. So the first example we're going to look at in this video is 4x equals 13. Now, we are supposed to solve for x here. Now, we can't, you look at this and like, okay, well, we could take the xth root of 13 on both sides, but that doesn't work because what is the xth root, right? That doesn't work. That doesn't jive. It's not gonna happen pretty, right? So what we do actually do, I put that. I'm gonna need this in a minute, all right? But for now, what we're going to do is we're going to take this in exponential form and we are going to convert this instead to logarithmic form, because logarithmic form lets us focus on the exponent, which is great because that's exactly what we're trying to solve for, right? So we can say the log, why we switched colors. I think I was going to do an intermediate step, but there it is. The log base 4 of 13 equals x. Now, in this one here, converting here, now, we don't have a log base 4 button on our calculator, or we probably don't. Well, we definitely don't have a log base 4, right? And so how can we solve for x here? Well, we can use the change of base formula that lets us turn this into x equals the log, or the natural log, same thing here, of 13 over the log of 4, right? Now that we can punch on our calculator. So on this HP prime graphing calculator, it's going to be real similar on TI-84 or whatever else. But on this HP prime calculator, we're going to find our log button that looks like this. And we're going to hit log of 13. Now we've got parentheses here. We can go outside of that parentheses and hit divide and do log of 4 and hit enter. And we get our final answer of x equals approximately 1.85. X is approximately equal to 1.85. There we go. Let's do one more example and then we'll be done with this one. I told you we're going to have these that are nice and short and easy to get to and access and all of that stuff. So this time we've got e's in there. E should give us the clue that we're going to use the natural log. This one's going to be a little bit different. It's going to be similar. We're going to use a similar strategy, but not quite the same to solve this one. That's what we're doing with all of these logarithmic forms. We're kind of looking at, it's kind of back to geometry almost, where we're learning this piece and that piece and all the pieces, and then we're going to use those pieces together as kind of tools in our tool belt to solve equations, right? So the e to the 4 minus 3x equals 6. Now we can convert this to logarithmic form, and I'm going to kind of show an intermediate step here. You could skip this very, very first step and go on to the next one, but I'm going to just so that we get full clarity and we get it all really clear, we would say if we were converting this guy to logarithmic form, it would be the log base E of 6. I like to put that parentheses in there. It's not strictly speaking necessary when it's just a single number or variable, but it's just clearer what's happening. Excuse me. Equals 4 minus 3x. Now, if you remember, and this is the step that I'm saying you could skip, the log base E has a shortcut way of writing it, and that is ln, or the natural log. So the natural log of 6 equals 4 minus 3x. Now, you could go ahead and punch this in and get the decimal equivalent now, but I'm going to go ahead and keep on going with where we are and keep it exact until the very end on this particular problem. So what we would do, of course, is we would subtract 4 from both sides and end up with the natural log of 6 minus 4. This is one of the reasons why I like those parentheses. It's not necessary, but it's much clearer that it's not 6 minus 4 inside of there. And so it gets your order of operations clearer. It's not necessary, but clarity is a good thing. So we're going to get rid of that negative 3 by dividing both sides by negative 3. Now, if we wanted the exact answer, like in a math class like this one is, then we could finish and be done right there and say our answer is the natural log of 6 minus 4 over negative 3. So if we're wanting an exact answer, then we're done. Now, we could also punch this in on our calculator and get the decimal equivalent, right? We could take this guy in here and we could grab natural log of 6 out of the parentheses minus 4. And then I'm going to go ahead and hit enter. If I hit divide right now, it's going to just put it over 4. Backspace out of that. So I'm going to go ahead and hit enter, do that numerator first. And then I'm going to hit divide. And on most calculators that are multi-line calculators, it'll give you the answer A and S, or all the words spelled out, which is this previous answer. And in this case, I'm going to divide by negative. The negative button on this calculator is up here. There's almost always a difference. But I hit divide twice somehow. Something's happened. Negative. The negative button here is right here on this calculator. It's almost always somewhere different than the minus. The minus is usually not the negative key. It's in different places on different calculators. On this one, it is right here. So divided by negative 3, enter. And so we get 0.74 as our approximate answer. And that is it. If you want some guided practices that go with that one really well, in our textbook, it's on page 192, and guided practices 4A, B, and C. That's it for that one. We'll see you in the next one. See you later.